Welcome to our webinar by Chronosphere and the Enterprise Strategy Group. Today, we will talk about the four foundational challenges of observability and monitoring. So, this starts with taming the overall complexity of modern application environments and infrastructure stacks, then optimizing cost and establishing cost transparency, getting developers to actually use the observability platform together with the operations guys. And then number four is monitoring AI models and AI model driven applications. This is a brand new topic, but is becoming increasingly important. With me, I have John Potokny, Senior Sales Engineer with Chronosphere. John, can you spend a few seconds to introduce yourself?
Sure, happy to. So you mentioned I'm on the solutions team at Chronosphere. I've been working in observability for over a decade now. Started off as a backend engineer for a database observability company. So I got to actually build out tooling for collecting, ingesting, processing data, all while being on call for the system. I also got to interact with a lot of customers on call for customer support. I've worked with probably hundreds of organizations at this point on various observability challenges in different contexts, whether it be database specific, APM, logging, strictly time series metrics and Prometheus, things like that.
So
Happy to be
you
here.
actually know how stuff works in real life. So
I
that's
built it,
exactly.
on call for it, used it.
Yeah. No, I mean that's always makes for the best conversations. So to crown the discussion, we will for each of those four topics we will present a couple of data points from the enterprise strategy group. And the enterprise strategy group, what we basically do is we help software vendors with their go to market, with their product strategy, with their content strategy, and in general, with whatever they need to being positioned in the marketplace in the best possible manner when it comes to their product portfolio. So from a research perspective for complexity, there's a couple of data points that are hard to ignore and that we've seen over the last few years as well. They haven't gotten all that much better, even though we thought they should be. And I want to start off with the 67% of respondents to our last research study that said that observability is fragmented and siloed across different tools and teams. And that gives them significant challenges when it comes to prioritizing and to the overall optimization of their ability to do root cause analysis and to give the developers ideal conditions for observing what their product does in real life. And in line with that, we see a tool proliferation. 39% of organizations use 6 to 10 different observability tools, and 10% actually use 20 or more observability tools, which is a tremendous number. And at the end of the day, when we then ask organizations, what is the most time consuming thing or task that is related to observability? Number one is really the adoption of or the adaptation of observability tools to the specific corporate requirements. Most organizations are in the middle of their application modernization process, so they still have a very large share of traditional applications and a increasingly large share of microservices applications, and figuring out how to monitor both at the same time while transitioning from one to the other is tricky for most organizations. And I want to stop there and I want to ask John, are you surprised by any of this? Are you surprised by the high degree of fragmentation that we are still seeing?
Honestly, not at all. When I think about the organizations that I talk to on a regular basis, uh, many, if not most of them, have uh, disparate system architectures that they're responsible for across their business. It
Mm.
can be by way of acquisition, it can be by way of evolution. But the reality is that uh, most companies that have been around for a while have, um, you know, two, three, maybe even more different types of fundamentally different software architectures that they have to
Mm.
manage and understand in production. And those different architectures have different needs, different use cases around how to understand and troubleshoot and get information from them. And there's usually tools that are tailor met to those different circumstances. So having different tools to handle different systems doesn't surprise me at all. If you start to subdivide the different concerns and use cases within each generational architecture that a company has, you end up with different tools too. Same thing with, if you are acquiring other businesses and they had tools that they were using might be different from your tools, even though you have the same
Right.
fundamental architecture. You might just keep the tools where they are. It's not broken. Why bother?
Mm. Mm. So how can you actually help overcome? Because as you said, multiple tools are not the problem, but data silos are the problem. So
Yeah.
how can you help companies overcome this issue with data silos so that they can actually make decisions within the bigger business context?
Yeah, I think there's a couple things here. As a vendor, right, working on an observability platform, the big thing for us is being cognizant of the needs of our customers. So at Chronosphere, we focus on cloud native observability. We know that we're not going to be the only tool that our customers use. It's just not a realistic expectation for us.
Right.
And so we try to make it possible to connect Chronosphere in such a way where if you need to traverse the boundaries of our platform into another platform, that should be as natural as it can reasonably be without us knowing what tools you are working with.
Hmm.
Creating those kind of generic contracts between our platform and others. Some of this is fueled by open source standards around the data that we work with. So we're totally open source compatible with things like OpenTelemetry and Prometheus on the read side as well for Prometheus metrics. Other times it's creating first class integrations and partnerships with tools that are tailor made to handle specific use cases that you might be able to do in Chronosphere, but you probably are more inclined to use a best of breed solution.
Hmm. Yeah, yeah. So tying together the data layer so that you can get context with every alert that you receive, I think that really is the key. And John, outside of software, what are other considerations that organizations have to look at when they are faced with all of this complexity? Because it's not just microservices versus monolithic, right? It's like a whole continuum of different architectures, and
Yeah.
it's often a combination between both.
Yeah, I think a lot of it comes down to what are the audiences that you're trying to serve for a given set of use cases, and where do they interact? So you might have different teams that manage these different systems, and there's very little overlap between them. Great, you don't have to worry about the different tools that are being chosen. When there's heavy overlap, you have to be a lot more conscious about how are these things going to work together. We're going to have to traverse the tool boundaries a lot in our day-to-day usage. And so, how effective are the solutions that we're looking at in enabling that process, right? Do we have to do significant customization or incur a lot of pain in order to go back and forth between tools? Are there things that we can do in order to make that easier? That's part of I think, the trade offs that organizations have to consider when they're looking at consolidation of tools versus splitting tools out for different use cases and adopting more of a best of breed approach. What are you getting by having a new solution for a given use case, and what are you trading away? Do they interact effectively together, or do they assume that they're the center of the universe?
Right, right. Yeah. At the end of the day, what you don't want is silos, right? I mean, I come back to that term all the time and pops up in our research all the time. As many tools as you want to have, as long as those tools talk, if you will, and you can actually collect data within its context, and all the different personas get the data that they need, and the alerts and the insights and everything that they need,
Absolutely.
then you can have dozens of tools. So, from a cost perspective, cost is still a big issue. We had all of those projects we were looking at situations where the cost of observability could actually be higher than the cost of the cloud resources themselves, which has surprisingly quickly happened. And looking at our research, when we ask customers, what do you see the biggest cost issues? the number one, a third of our respondents, our study respondents, said that it is features that we are just not using. We sign up for all of those capabilities and features, and at the end of the day, our people, they don't even know that we have them, and a very small fraction actually are using them. And then another piece, and that has come through open telemetry, I think, quite a bit, is high storage cost, where it makes it easy through open telemetry, or at least much easier to open telemetry, to do your auto instrumentation, or to use as a developer those instrumentation libraries that are very handy SDKs in your development environment. And it's quick that you generate massive data streams, and who knows if you actually need them, and you run up tremendous storage costs. John, you were laughing. Go ahead. Is that something that you see as well?
Yeah, absolutely. There's a lot of contributing factors, I think, to the rising cost of observability. But the first and foremost in my mind is uh, giving people a better understanding of the telemetry that they're emitting as an organization from their various applications and infrastructure, and how they're actually consuming it in practice. Are they using what they are paying to store in a given tool or solution? Uh, if they are, then great. Um, is the data in the most optimal format compared to how they're consuming it and the insights they derive from it? Maybe not. In a lot of cases, people are sending huge amounts of information that they never even look at. I think of that a lot in the when you mentioned features that we have that people aren't even using. It's very easy, I think, for organizations to generate dizzying amounts of raw telemetry and insight about the systems that they are responsible for. But in practice, they probably only need a small fraction of it to actually understand their system on a day-to-day basis, and they pay for an order of magnitude more than what they actually consume.
Yeah.
I think of this as we all understand and agree that it's important to have observability into the systems that we operate. I think we also need to have observability into the observability that we use to get that
Mhm.
visibility.
The magic lies in the pipeline, right? You have to give the observability pipeline some feedback in terms of what it should collect. So OpenTelemetry can, of course, collect anything in the highest possible resolution, but it has to come back from the platform, right? There has to be some intelligence that says, those logs are basically the same, and collecting another 5,000 of them per hour doesn't help us.
Yeah, the having the analytics in place is definitely, I think, one of the most important pieces. Being able to actually show folks where they get value and where they're not, and to your point, where additional data is hitting that point of no longer adding more value to the system.
Hmm. Hmm. And then, yeah, I mean, there's of course that old topic where developers, they like to turn everything on because more is better, and as long you're not going to miss something if you want to debug, or if you want to observe performance of the latest release. They like to turn everything on, and there should be some type of governance that doesn't deprive developers of the ability to observe their application in production, but at the same time, it should also rein in what they can do if it doesn't make sense. Is that something that you are able to take on in your software, in your observability platform at Chronosphere?
Yeah, so we have the idea of centralized governance with federated control. So being able to have a central observability team define quotas, define guardrails around how much capacity a given workload or a given team should be able to actually consume in the system, and then those teams can then go and use that capacity how they see fit, with detailed visibility into where they at versus the quota that's been given to them. If they're bumping up against or going over that quota, where is the data that is driving the costs coming from, and how is it being used by the team? Giving all of that insight to the team so that they can go and make smart trade-offs about what they're collecting and paying for in the system versus what gives them the most value.
Yeah,
Uh,
and I mean, it's key that people are not afraid to
Yeah.
monitor, right? We hear those horror stories where all of a sudden at the end of the month there's a gigantic bill that you didn't expect, and then next time you're going to be much more careful, but then you don't get the data that you actually wanted to get. So it's a fine line, and you have to really reach that balance.
Yeah. And in my experience, engineers are very, very cost conscious in a lot of cases. It's just a matter of making
Mhm.
it clear to them what the consequences from a cost standpoint are for turning that additional bit of instrumentation or that additional feature that they're looking at compared to the incremental value that provides.
Right.
Once you start to give them that visibility, you start to see a lot of more thoughtful choices being made about the system and the data they collect.
Right, but there's also choices that you don't necessarily even understand the implications of. Like I'm talking
Sure.
about a high cardinality problem, right? You add different dimensions of metadata that you collect. You enrich your data with, like location and
Yeah.
maybe how many users are using your app at that time. You can do all kinds of metadata and you enrich it, and then you create basically multipliers for the amount of your data. Is there something that you can do that proactively protects you while still letting people add the metadata that makes sense?
Yeah, absolutely. This is one of the central things that we think about at Chronosphere. It's very near and dear to my heart.
Hmm.
Dealing with cardinality explosions as an on-call engineer for TSDB.
Right.
um, be, there are a few things that we do specifically for our customers. One of them is the idea of creating a license model where introducing a cardinality explosion does not automatically result in a scary bill. Creating a little bit of psychological safety for our clients, right, where they don't have
Right.
potentially shocking monetary consequences to making a mistake,
Yeah.
and then giving them tooling to rapidly identify if there is a much higher impact on the overall cardinality of adding that additional label or dimension to their metrics than they expected. Um, where is it coming from? What dimensions have high cardinality in the system? And again, going back to, are they actually valuable? It's okay to have high cardinality data for our systems. With cloud native architectures, you're bound to run into something that has hundreds, if not thousands, of unique instances that you want to be able to track.
Right.
Particularly when you get into business metrics and want to track on like a per customer basis, things like that.
Yeah.
That's one of those good problems to have, uh, as long as it's again enough value for the cost that you are consuming. And if there are other things that are inflating that cost that you don't rely on, then giving them controls to go and aggregate away the unnecessary dimensions and the granularity to understand which dimensions are versus are not necessary in practice. Uh,
Right. Right. Or you can just tone down the resolution a little bit, right? If you want to
sure.
see how a large user load impacts your application performance, you can just do categories and don't have to count individual users. You can say more than 10,000, more than 100,000, more than a million, or whatever, as
Absolutely.
opposed to each number, right? Yeah. Um, so yeah, so that leads me to the next topic of developers, and we've talked about developers a little bit before, and I think developers are important in everything that we do because obviously they are responsible for adding new cool or useful capabilities to the software. I should say useful, not really cool. I don't think they care about that, but what we often see in our research is that developers do not use the corporate observability platforms. They prefer to do their own thing. They prefer to have their own. And we see that is the case in roughly half of organizations where developers say, no, we don't really have a joint platform that would make sense for us, that our ops guys are giving us, that we are also using. So we are doing our own thing. And often that is the case because they find it too difficult to use. They don't really know how to query. They are worried about doing things wrong and not fully understanding, or they get dashboards that are partially meaningless to them. So there's a lot of info that's available, but developers, they just need we always like to say they need insights, right? They need something that's actionable. They need their question answered, John.
Yeah. Yeah, absolutely. And I hear this semi-frequently as well when I talk to customers. I think there are a couple of different potential reasons for it. One of them can be the way the organization is structured. So very large organizations might have a central team that is making tooling decisions for several different lines of business, right? But those
Mm,
lines of business have very different competing concerns and situations that they're trying to
right.
operate within. And depending on how much overlap they have, it makes sense for them to not have different tools. Standardized tooling sounds good from a central point of view when you want to buy one tool and manage it for all the lines of business. But if your disparate customers, the lines of business, have different needs, then they should have different tools. Um, Other times, it may be a case of not sufficient um, support, maybe for the teams. You've bought a tool and it should meet their needs, but it requires a little bit of tailoring, a little bit of customization, a little bit of template in order to make it easy for the different service teams to get the most value out of it and be able to understand it. And when you have cloud native systems like the ones that Chronosphere are tailored for, the level of interconnectedness between different service teams, it's important that teams not be able to understand just their own system, but also the ones that are surrounding them too. Um, and that's a case where having a central observability team put some standards, some templating into the tooling as well to help them understand their services can be very valuable too. Taking a tool and giving it to the teams and say, here you go, you can use this to understand your systems. And then every team creates a service dashboard of their own and they all look completely different. Makes it very difficult for somebody to go and understand, how am I interacting with the services that are around me from a dependency standpoint. Uh, and if that question can't be answered, they're going to throw away the tool because that's a really important question.
Right. And that's a good point, right? If we talk about microservices
Yeah.
and really breaking down functionality more and more, then just figuring out what microservice is the culprit here is already tricky, right? That's where you have to start.
Yeah.
And so what is really different about monitoring in the world of microservices versus back in the days of monolithic applications, right? I mean, one big point is what I was just alluding to, and that is if instead of one app, you have 25, 30, 40, 50, sometimes microservices, you have to figure out where the issue is, or the issues could be in an interaction between multiple microservices. It could be in all kinds of things that you do not have in your local development environment as a developer anymore, right? You have to really do distributed tracing there. Um, John, what do you see there as new kinds of problems that are getting more prevalent when you see organizations that are further along with microservices compared to the ones that have just started?
Yeah, it's funny because I think the difference between microservices and cloud native architectures versus when we were doing more monolithic on-prem and shifting to the cloud, the difference is a lot different going from just kind of cloud running VMs to microservices than it was on-prem to cloud.
Yeah.
If I think about my engineering time when I was first starting out in the engineering team, our system was not a monolith, but fairly monolithic in the sense that every request that hit the backend was handled by one or two services. It
Right.
was very easy for me to have the entire lifecycle of a request in my head when I was going and troubleshooting.
Right.
Uh, Very much not true with the modern systems that the customers that I work with are building and maintaining. There's a lot of complexity that can arise in the life cycle of a user's requests. You click a button in a UI and it goes and hits a couple dozen services, if not more. And that means that understanding the dependencies between things and understanding how services interact with each other has suddenly become a very important thing that we have to pay attention to. Whereas before, it wasn't as much of an issue. I knew where the problem was almost instantly when I got
Mm.
paid. It was in the service that I got paid for. These days, it could be in a service
Right.
5 steps removed. And figuring that out
Yeah.
cannot or can sometimes be a very difficult conversation. The other thing that springs to mind for me is the rate of change for these systems. We've broken down our systems into more and more smaller services so we can change them more frequently independently.
Yeah.
is good, but it means you have more opportunities for problems to be introduced. And it's easy to change something that on its own works great, but something, a few steps removed that depended on that specific behavior now is broken.
Yeah.
So those types of issues happen all the time.
Yeah, yeah, and
Um,
there's also third-party microservices there that you may not even control that could cause
Absolutely.
the issue. Yeah.
Yeah.
So what would you say is the critical element that you have to do or to ensure so that developers will actually use an observability platform? What is the key? I mean, we said they need something actionable, they need insights, right?
I mean, it's a simple sounding thing, but it's very difficult, I think, to implement in practice. But really, what we're talking about is giving them a clear on ramp to get visibility into their systems at a high level, and then giving them a clear workflow for how to go and turn that generic visibility into insights when they are trying to troubleshoot a problem. Is it straightforward for an engineer to, given an issue with their service or a request that they're debugging, understand where the problem is coming from and what the nature of the problem is? Uh, we just
Not
talked
just more dashboards, right? They have enough dashboards already.
about very much no, yeah. Like we just talked about, the nature of the problem has changed a lot between generations and software architecture, and so the tools as well have to change. I think pretty significantly in order to adjust to that. So if you
Hmm.
try and take the tools that you used previously and adopt them to your cloud native architecture, you're gonna have a bad time. But it's true going in reverse, right? Like you could use Chronosphere to go and monitor a mainframe, for example, but it's not the best tool for the job by any means.
Right,
Uh,
right,
that's how we get the proliferation of tools that we talked about previously.
right, right. Yeah, and from a cost perspective, it's actually an interesting question. We talked about cost before, but from a cost perspective, how can you incentivize developers to use the observability platform? How you can you make it less prohibitive? How can there be less of an upfront commitment that you have to give?
Yeah, I think a lot of it comes from having a centralized team that is dedicated to making that easier. Things like open source standards and auto instrumentation using OpenTelemetry or eBPF even can make it a lot easier to get visibility, to get telemetry from different systems without requiring a bunch of code changes, and that certainly helps. Um, Creating things like uh, custom templates in shared libraries is another great way to approach this. So the Central Observability team takes on the work to go and create a wrapper around OpenTelemetry and add it to the gRPC or whatever other communication library you use in your system. You can get visibility, quote unquote, for free from a service owner perspective your system just by going and adding the package. I think that lowers the barrier to entry a lot. And then it's just a matter of, does the tool solve my problems?
Right. And I think the pricing model of the platform also plays a role, right?
Yeah, absolutely. You want to make it so that you can do these types of things that are turned on by default, but not incurring significant costs until teams start to actually consume them. And
Right.
that goes back to one, being able to understand who's using what and how, so that you can know what is safe to turn off versus what is being relied upon, and then also
Mhm.
giving people uh, easy ways to control the spigot of data that you're paying for without having to go and make obtrusive changes to the services themselves.
Yeah. I think that's a general issue in software, right? Companies don't really mind to pay for stuff that's valuable.
Yeah,
So if I knew that my developers are using this, I wouldn't mind buying them annual licenses, but I just don't know that. So charging them based on consumption, at least in the beginning, makes a lot more sense so that they can see, ooh, this is actually useful, and they use it more and more and more. And then if you see that they're all using it like crazy, you can still talk about maybe a discount or different pricing model, but that initial threshold to try has to be as low as possible. Otherwise, they'll just keep doing their own thing.
yeah, and making it clear that the growth in the cost is not unreasonable either.
Right.
We see a lot with consumption-based pricing models where it's easy to get started and easy to onboard, and it seems very reasonable upfront. But given enough time and enough opacity into how you're actually growing your workload and consuming the data that you're sending to the platform, eventually it starts to run out of control. So it goes back to that notion of we need to have good meta observability in order to make
Right.
sure that the growth in cost for the system is not outpacing the expectations of the business.
Hmm. Yeah. And let's move to the final topic for today, and that is AI observability. AI is, we will just keep saying AI, right? We all know what we mean by that. Today, when we talk about large language models, is a very interesting topic here because they put a ton of strain, like everything that has a neural network behind it, right? Puts a ton of strain on the infrastructure, and over provisioning becomes prohibitively expensive. When you talk about expensive GPUs and uh, super fast storage, all of those things, you can't just keep doing what you used to be doing. And in our research, when we asked companies, oh, how are you able to actually observe and monitor your AI? Do you have specific capabilities for that? 78% said yes, we actually do. We are able and ready to monitor AI, which is interesting. And you'll probably get a kick out of that, John, as well, because then if we keep asking further, about the individual problems that they still have, it turns out they still have all of the different problems that you can have with AI, right? From cost to performance uncertainty to synchronizing the MLOps process with the DevOps process. I mean, this is everything that you can basically imagine under the sun. They still have, even though at least they believe they have made, or they actually have made a first step toward being able to monitor their AI in the way that it should. What's your out there in the wild when you look at customers? What do you see there with AI observability? Is it there yet? Is it there partially? Is it still in the beginning?
I mean, I think by definition, it's still at the beginning. It hasn't been around for long enough for us to say that
Right.
super mature. That being said, I think of AI observability as just observability for another application in a lot of ways.
Yeah.
There's a specific set of KPIs that you probably want to be able to understand when you're looking at AI LLM interactions, and how your usage of AI relates to the rest of your stack, right? And that's not a particularly complex problem in the sense of I think we all understand the KPIs that we probably want to be able to track. The interesting part in my mind is when we start looking at specialized solutions, how much further do they go, or how much easier do they make it to go in and turn again raw data into insights in a way that makes it compelling to have a separate solution versus do I just go and generate metrics from my application on how we're using our LLM and then send them to my observability platform. Doing the latter is quite straightforward. The question in my mind is where people are doing something with a specialized tool, are they getting the value that they would expect out of it? There's probably a lot of room for improvement there, but it is still early. So
Yeah, I mean it's still early, right? Because this is only one aspect of monitoring a LLM. On the other side, I just had a couple of really interesting encounters with a couple of LLMs myself, where you need to actually monitor their usefulness to the customer because it's not a rule-based system, right? You don't exactly know what's going to come out, and you need to also be compliant. So you need to keep logs of all of their answers in a lot of cases that they gave. You need to make sure they are not using foul language, or they cannot be provoked into crazy answers. There's a lot of aspects that we haven't thought about that also entails. And in that regard, we are definitely also still at the beginning, right? And the question, as you said, is: do you need specialized tools to look at that layer, or should you use the same tools and add capabilities that can do those things? And I think a lot of that depends on the use case, and at companies like yourselves working with clients to understand what's going on in real life out there.
absolutely, yeah. One of the interesting things that we've run into kind of on a semi-regular basis talking to customers about AI observability use cases is the scale that's involved.
Right.
Particularly when you start to talk about getting into um, developing and training your own LLM. It's incredible how much infrastructure there is behind the scenes. You called that out earlier, Torsten. You may have uh, huge amounts of machines with GPUs just doing nothing but training and inference workloads nonstop, and having any not just downtime but any inefficiency in the usage of those machines can be a significant expense for these organizations, given the amount that they pay for the systems. That plus the massive cardinality of the data being generated. If you're doing this type of workload when you're training an LLM, you're probably not just training one, you're doing tons and tons of different A/B tests. And so there's not one model, there's dozens, hundreds, thousands of models with different variations and tweaks that you're testing out to see which one is most effective for your customers. And that results in a huge amount of cost for one use case.
Yeah. And that's again, I mean, that's exponentially more cost than traditional software, I think, because the hardware is just so expensive. Like the smallest GPU array is in the 30,000s, I believe. And you can't just say, okay, I'm going to use 5 instead of 2 just to be on the safe side. And you can also not say, ooh, I used this for 2 weeks out of the quarter, and the rest of the time I leave it standing around. You can do that with servers. You can leave EC2 servers on by accident or on purpose because you don't want to bother turning it off. But if you leave this kind of workload on, you causing yourself a mountain of cost. And the same is true from a observability perspective as well, because you just have such clustered systems that are so much more complex and resource intense that it's very easy to spend a whole bunch of money without getting anything in return.
Yeah.
It's
Whether you're paying by the hour in the cloud or paying upfront for the
yeah,
server you've racked in a data center,
yeah,
getting the most out of your hardware spend is a huge challenge in the space.
yeah. GPUs on demand are no guarantee that you get better value out of it. That's one of the things that I've seen recently. So, thank you, John. Overall, what we've talked about today is the 4 key challenges in observability. Complexity basically boiled down to data silos that we have to avoid. It's okay, we said, to have multiple tools, or even a larger number of specialized tools that everybody, individual personas and teams, feel comfortable with. But what we do need to make sure is that those tools talk so that we get context and can actually provide actionable insights instead of just more disconnected dashboards. That was number one. Number two was the cost factor. John, we need to make sure that we have a proper pricing model in place uh, that lets everybody use that system without having to worry, and it also reins in the pipeline and provides some level of governance uh, about in terms of how much data you ingest and where you store it and how long you store it for. So there's all kinds of considerations that you have to look at, and you have to govern that centrally. Even if you have multiple tools, there needs to be a central governance instance there to take care of that. And the third one was to get developers to participate and to actually benefit from observability platforms in a way that makes sense, so that they basically, from all the work that the observability guys, the SREs, the platform engineers, the cloud engineers, all of this data that they're producing, developers need to be able to benefit from that and use it to enhance their own applications based on that. And finally, we were talking about AI and all of the new challenges there will be, or there already are, when it comes to providing observability and visibility and overall monitoring for AI models. Because while it's also to a degree just infrastructure and application monitoring, there's also another aspect to it, and that is vastly different from standard monitoring, because it's about what you get back from the application, what it spits out. You have to make sure that that stuff actually makes sense, and it keeps making sense, and it continuously makes sense in the future. John, thank you so much for joining today for this conversation. Is there anything I forgot? Any last words from your end?
Uh, Nothing that springs to mind. No, I don't think so. Thanks for having me, though.
Well, thank you very much.